video will cover is your parent rational, and what we intend to do here is look at the parent function of our rational function, which has for the equation 1 over x. And we were discussing how from the domain, we will have to exclude 0, because if we were to divide by 0, then that will give us an undefined answer. So let's answer these two questions here. Why is this function rational? And the reason for that is because it is a ratio of two polynomials and x is present in the denominator. And why do we call it parent? Because it is the simplest form of a rational function, meaning that it has no vertical or horizontal shifting, it is not stretched, it is not nothing. It's just the simplest form that you will find. There are other names to it. One of them is the reciprocal function. And that is because if you were to find, for example, here, what is f of 10, you will substitute 1 over 10. And so what is 1 over 10 as a decimal? 1/10. So that is why we could call it the reciprocal function, because 1 over 10 is the reciprocal of 10. So what I need you guys to do now is to grab a calculator, and don't do it yet. Let me show you what you're going to do. So I don't want you to graph it and then go to the table. What I want you to do is to divide on the calculate part of your calculator. So, for example, right here, I'll do this one. You will substitute 1 over -10, and so that will give you -0.1. So I want you to do the same with every single value that you have here for x. Complete the table, and then you're going to graph it. And after plotting the points, of course, I do want you to connect them. Yes. So I'm going to go ahead and pause the video so that you can get your calculator and start working on that, okay? So we have our table of values here, and our students found all the y values that correspond to each x value. At 0, since we know we cannot divide by 0, we will say that it's undefined. So now we're going to plot the points. So we have 1, 1, we have 2, 0.5, we have 5, 0.2, and we also have when x is 0.5, the y value is 2. When x is 0.25, the y value is 4. And now I'm going to connect them, but I need to be careful not to touch the x or the y-axis, and we'll look at that in a minute. We'll see why. Now I'm going to graph what goes in quadrant 3. So at x equals -2, the y value is 0.5. At x equals -5, the value is 0.2. And so we connect them. And so that is the graph of a rational function. Now, I want you guys to turn your head about 45 degrees to the left, like that. And so what you're seeing here, if you're turning your head, you should be looking at something that looks like that, right? Yes? That is called a hyperbola, right? We're going to look at those in pre-cal too, hyperbolas. And we even do this thing called rotation of axis, which is what you just did with your neck, 45 degrees. So anyways, going back to rational functions, I want you to try this on your calculator, and without saying anything, just write them down. Find some room on your paper to write them. I want you to divide 1 over 1,000. And then I want you to divide 1 over 10,000. And then I want you to divide 1 over 1 million. And just write them down on your paper. And of course, press Control Enter so you can get an approximation. Control Enter, don't forget. Okay, so Alexis, what do you get for the first one? 0.001. Okay. Raquel, what do you get for the second one? How many zeros?
3.
Okay. And Matthew, you get the third one?
4.
How many zeros? No, this was a million. Are you using your intuition to tell me this? Okay. So what could you guys tell me? Which number of the ones that I'm circling is the smallest? Hold on, I just made like a... Okay. It's not a mistake, it was just not where I was trying to go with. Okay, so since we already did this, okay. So I'm gonna make the following argument. As the x value increases, meaning it goes to infinity, it gets larger, right? Like we went 1,000, 10,000, and then a million. What's happening to our y values? They're decreasing, and they're decreasing to what? Smaller and smaller. If I had to make a guess, I would say that like we're gonna keep getting zeros there. So eventually, we're gonna get closer and closer to the y values approaching what?
Yes.
The x-axis, very good. And so we could also say y equals 0, because that's the same as the x-axis, right? The horizontal line y equals 0.
Would you ever hit 0? You just keep adding that from it.
It will just keep getting smaller and smaller, but not touch 0. And so that right there could give us an example of a horizontal asymptote. We could say the y values approach a horizontal line. Okay, now if we look at the left side, it's the same thing is happening. The y values are approaching the x-axis, but they're not going to touch it. Kind of like exponential functions, remember? They had a horizontal axis. Now, let's see, I want you guys to try the following. I want you to divide on your calculator the following things. So now what I want to do is get closer to x equals 0, okay? So I'm going to pick numbers like this. 1 over 0.0001. And then I'm going to pick 1 over 0.00000. And then one more. 1 over 0.00000. So if you guys could divide those for me, please. Okay, so Marco, what do you get on the first one? This one right here. 10,000. Okay. The one in the middle? Okay, and then the third one. Go ahead, Marco. Tell me how many zeros. How many zeros? Seven. So 10 million. Okay. I'm not so sure they're okay, but I am sure of something. The smallest that we pick our denominator or our x value to be, what happens to the y values, guys? Are they increasing, decreasing? What's happening to them? They're increasing, right? We're going from 10,000 to 1,000,000 to 10 million. So what's happening here, what do you guys think you will get if I keep adding zeros right here? Like another 0, and then another 0, and another 0. Your values will get larger and larger, the y values. So what we say is that when we approach x equals 0 from the right, and this is how you're going to write it, as x, and then arrow, approaches 0, and then a little plus on top, a tiny one that looks like an exponent, that means from the right. I'm teaching a pre-cal right now, and calculus, believe it or not. So as x approaches 0 from the right, the y values approach, they get larger and larger and larger, and I'm going to say they increase without bound. So what is that number or concept that we use to denote that? Infinity. Very nice. Infinity. Do you guys see this? They're going up to infinity. Now, let's see what will happen if I was to do the same, but approaching 0 from the left. Negative what? Negative infinity, yeah. So, as x approaches 0 from the left, the y values will approach negative infinity. So when we have those type of situations, where on one side of the, by the way, I was saving this for later, but let's just throw it. So right here, this one is going to be the vertical asymptote. So for those type of asymptotes, let's say, when you have on the left side of the vertical asymptote, the values are going to negative infinity. And on the right side of the vertical asymptote, your values are going to positive infinity. When that happens, then you create that discontinuity. And so what is between the discontinuities for this case will be the vertical asymptote. So let's write down vertical asymptote. The y values increase and decrease without bound on both sides. It could also be one side only, but for this one, it's on both sides. Also, a very friendly thing to say about an asymptote is that they, your graph is not going to touch it. But that only applies to the vertical asymptote. Okay? It's also an imaginary line. I ran out of space. I'll write it here. Imaginary line. And I say imaginary because if you graph a rational function on the calculator, it's not going to show you where the asymptote is. So it is an imaginary line that the graph won't touch. Horizontal asymptotes, they could be touched. Verticals, not. All right. The vertical asymptote also comes from the number that you exclude from the domain. Remember at the beginning we said for this function, x cannot be 0. So like I was saying, right here we determined we must exclude 0 from the domain, right? So that one is also going to give you the equation of the vertical asymptote. So this question says, where are the asymptotes? Well, the vertical asymptote is located on the y-axis, but we have to give it an equation, and that equation will be x equals 0. That's for the vertical asymptote. Now we also have a horizontal asymptote. And that one is actually this line here, which happens to be the x-axis, and the equation for that would be y equals 0. Now, how does this affect the domain and the range? I already kind of talked about it. X equals 0 must be excluded from the domain. And also because we have that horizontal asymptote, y equals 0 will be excluded from the range. The range. So remember, the domain is the set of all x values, and then the range is the set of all y. Let me write it down. We need to make some space. Anytime now. Okay, excluded from the domain. And then the y equals 0 will also be excluded from the range. Okay, so how will we denote the domain and the range? We will say this. In interval form, it will be from negative infinity to 0, union 0 to positive infinity. Or for the range, same thing, from negative infinity to 0, without including 0, union, and then 0 to infinity. Now, how could I write that in set notation? Well, the domain, it will be any x such that x belongs to the set of real numbers, and x cannot be 0. How do we do that with the range? What should I do instead of writing any x? I cannot use x. What other variable do we have? The y. So any y such that y belongs to the set of real numbers and y does not equal 0. And that's it. Now what I want you guys to do is within your groups, I want you to look at the graphs that we have here, and I want you to find me the asymptotes. Draw the asymptotes. Don't worry about stating the domain. I would like for you to find two things for me. The vertical asymptote for all of them. And also the horizontal asymptote. Oops, actually I shouldn't be writing this. It's wrong. And feel free to use a color pen, highlighter, color pencils, whatever you want. So let's say vertical asymptote. Will that be x equals to a number or y equals to a number? X. So you need to find that number. So do that for all. Don't just give me a number, you need to write x equals. And then I also, of course, I want you to find all the horizontal asymptotes for me. And so we will not have x equals to a number, we will have y equals to a number. So go ahead and, oops, I gave you the answer. Yeah, actually that's the answer for that one. And then also try some on your paper, okay? I'm going to pause the video and then we'll come back to check our work. So, let's check our answers. Jasmine, what did you get for the first one, Berkeley? 2. Isaac Hassel, the next one, Berkeley?
-1.
-1. Isaac Silva, next one, Berkeley? 3. Very nice. Now let's review our horizontal ones. Angel, what do you got? Next one, the second one, horizontal asymptote.
2.
Positive, And let's see. It looks like they're done. Matthew, you got it? The very last one, or not yet? -2. Okay, now you guys remember a little thing called function transformation. If I was transforming the rational function, I'm going to tell you right now what the equation will be. The first one was not shifted up or down. It was only shifted 2 units to the right, so it's going to look like this. It's -2. Why is it -2? Because horizontal shifting is counterintuitive. You guys remember that? The next one was shifted 1 unit down. I'm sorry, 1 unit left. So I'm going to have x plus 1. And then it was also shifted 2 units up. I know that because of the horizontal asymptote. So I'm going to have a plus 2 out here. And the very last one was shifted 3 units to the right. So that will be 1 over what? 3 units to the right. -3, very good. And it was also shifted 2 units down, so that will be a -2 out here. Okay? All right, so this is the end of this video. What I want you guys to do now is work on the other side of this paper, and you are actually going to do this all on your own. You have to work on your own, and you do have to finish it by the end of the period. You must. This will be on your binder that I'm going to grade, and if you don't have the stamp, it will be considered as if you didn't do it. So please make sure you use your time wisely and you work on this assignment that is on the other side of the paper.